Hello everybody, it's great to meet you. My name's George, I work at thoughtbot, and today I'm going to be answering a question. Does progressive enhancement have a place in today's web? Well, the answer to that question is yes. Question answered, job done. See you all next time. That's not a very satisfying answer though, right? We can't just say yes. Even if progressive enhancement does have a place, even if you believe me, what is that place? What does it look like? So to try and explore that a bit, we're going to answer 3 questions. 1, what is progressive enhancement? What am I even talking about? 2, what's the alternative to it? And 3, how do they compare? And hopefully by answering those 3 questions, we'll figure out where progressive enhancement fits into the picture of the web today. So what is progressive enhancement? Well, it's a way of building web applications that's very similar to making a sandwich. Why do you make a web application? You do it to solve somebody's problem. Somebody wants to read the news or manage their schedule or manage their tasks, talk to their friends, and you build a web application to help them do that. Why do you make a sandwich? Because someone's hungry. It's solving a problem. When you make a sandwich, you start with a piece of bread. And if you think about the problem you're solving, the problem of someone being hungry, this could solve the problem all on its own. In many ways, this piece of bread is the minimum viable sandwich. That term's going to be showing up all over the industry soon, I'm sure. The minimum viable sandwich, it's not very interesting, it's not very exciting. I wouldn't be very happy if I came round to your house for lunch and this is what you gave me, but it does solve the problem of being hungry. When you're building a web application with progressive enhancement, you start with HTML. Just plain old HTML, nothing else. You put as much content and as much interaction into that HTML as you can. Like our piece of bread, it's not very exciting, but it's the minimum way, the simplest way of solving the problem using web technologies. But like this piece of bread, people aren't going to be that interested. So we add more ingredients. Maybe we add some lettuce and tomato to our sandwich. Those could be like the CSS in our web application. The CSS kind of spices things up. It gives it more flavor. It can tie it to your brand. It can give it character. It can introduce visual hierarchy so that people find it easier to figure out what's going on. And it can introduce interactions that you can't do with just HTML. You can use pseudo classes like hover and target to kind of show and hide things and make stuff a little bit more interactive. It's a better sandwich and a better website once we've added a few more ingredients. But maybe we're not finished. Maybe we add some cheese to our sandwich. The cheese could be the JavaScript in our web application, something that adds even more interactions that we couldn't do with just HTML and CSS alone. Now we can build all kinds of fancy things. We can ask for the user's location. We can do real-time upgrades with real-time updates with WebSockets. Maybe our sandwich is finished now. So we're building in a layered way. We're starting with the simplest technologies we can, and we're adding layers on top that don't replace the layers underneath. They just add to them. They make it better. But the great thing about building a website or a sandwich in this way is that you get flexibility. There are 4 reasons to leave an ingredient out of a sandwich. 1 is that it ruins the experience of the sandwich for somebody. Maybe you find out that one of your friends who's coming over for lunch is lactose intolerant. You didn't know that, and you were planning to put cheese in their sandwich. You probably shouldn't do that. It's going to make them sick. Similarly, you might find out that a bunch of people using your web application are on really slow mobile connections. And it turns out that those web fonts that you were using that you thought made the experience better actually make it worse for these people on mobile devices because they load really slowly. And reading the title of your article in Helvetica quickly would be a better experience than waiting 30 seconds for the web font to load. Second reason you might leave out an ingredient, someone might just choose not to have it. One of your lunch guests might say, oh, I don't like tomatoes, and pick them out of their sandwich. This is like people who disable features of their web browser. Now, disabling entire large features like JavaScript or CSS is very, very rare. But disabling smaller things is much more common. For example, a lot of people use the Ghostery plugin. A lot of people turn on the privacy protection in Firefox. Both of these things block the browser from loading Google Analytics. If you've written your JavaScript in a layered way where you assume that each new technology you use, each new service you depend upon is a separate layer that's enhancing it but isn't required, then people can block Google Analytics. There's a great blog post on the Mozilla dev blog, which there'll be some links and stuff at the end, and there's a great blog post about this. If you follow the kind of recommended Google copy and paste this code to do event tracking, and people block Google Analytics, you can blow up all of your JavaScript. It's great. But if you take a layered approach and treat it as a separate thing from the rest of your JavaScript, you're OK. So your ingredients of your sandwich might do people harm. Your ingredients of your sandwich might be things people choose to ignore. What else? Well, you might find that when you go to make your sandwich, you open the fridge and you've run out of something. This, maybe I'm stretching the analogy now, but this in your web application could be like when you're using a really fancy new web technology. Maybe you're using service workers. Service workers are great. They let you run some JavaScript whenever a network request happens, and it can return a response without ever hitting the network. So you can do things like local caching. You can do offline experiences. You can have offline defaults when your AJAX requests fail. It's really cool stuff. But as of now, in the major browsers, it only works in Chrome and Firefox. Safari and Opera don't have it yet, and IE doesn't have it yet. So if you build in a layered approach, it's OK if that one thing is missing. Final reason is that something might just fail. Maybe you've carefully sliced your tomatoes, and as you go to put them on the sandwich, you slip, and they're all over the kitchen floor. Networks can be fragile things. Maybe someone doesn't get your JavaScript. Maybe it doesn't finish loading. The British government, the Government Digital Service in the UK, did some research on this. It's about 3 years ago, so it may not be entirely accurate now, but they found that 0.9% of their users had JavaScript enabled, but the JavaScript never ran because it didn't ever fully make it to the browser or get parsed or executed. Something happened that stopped it from running. Now, that may or may not apply to you, depends on your demographic, depends on who your users are, depends on their devices, their network connections. Maybe your numbers will be higher or lower. But for the UK government, it was enough for them to say on their websites they were going to build in a layered way so that if their JavaScript failed, people could at least see their core content. So sandwiches are the way of building web applications. Maybe. Maybe not. What's the alternative? What else could we do? How else could we build our applications? Well, there are several other approaches, but the one that's really gained popularity over the last 4 or 5 years, the one that you often hear talks about at Rails conferences these days, is single-page apps. You have a Rails app that's an API that serves JSON, and you have a front-end application written in JavaScript. I think of this less like making a sandwich and more like making a loaf of bread. The minimum viable loaf of bread involves all of the ingredients of a loaf of bread. You can't just weigh out your flour and then stop and say, here you go, lunch. It's not really going to work. You have to get the bread, you have to get the yeast, you have to get the water, you have to go through the whole process. And similarly, with a single-page app, you need the HTML to load the JavaScript, you need the JavaScript to run and load the JSON, you need the JSON to be parsed by the JavaScript and rendered it with the templates, and then you get your web page. So where progressive enhancement gives us flexibility, what do single-page apps give us? Well, they give us a world where we can build desktop-like experiences, native-like experiences in the browser. So what should we be building? Should we be making sandwiches or should we be baking loaves? What's the difference between these two approaches? Well, there are lots of things that are different between them, but a lot of them boil down to one core root cause, which is complexity. There's a very different complexity profile between these two ways of building. So let's take a look at how a browser interacts with a web application. Here's a simple model of a browser. There's a lot more going on in a browser than this, but at the bottom we have a parser that can get stuff from the network, figure out what it is and how it should be used. It gets turned into an object model. That's like the DOM in your browser. It's a parsed version of the HTML that can be used by the browser to render a page. It gets pushed through the renderer into a GUI that the user's interacting with. So back in the early days of the web, before there was any JavaScript, how did a browser interact with a web application? Well, the user did something in the GUI. They clicked on a link, or they typed in a URL, or they clicked on a button to submit a form. A request went out to an application. I've called it a Rails app because here we are at WindyCityRails. Let's assume we're building our backend in Rails. And it returns a response, which goes through the parser, updates the object model, updates the renderer, and the page updates. And now the user's presented with some new choices. This isn't very powerful. This is like our minimum viable sandwich. It's like our single piece of bread. But it's conceptually quite simple. It's easy to reason about. There isn't a lot of things like mutable state going on here. There's the properties of the request that come in, and that dictates what response comes out. And then there are some things that the user can do with that response. Let's add JavaScript into the picture. See what happens. So now we have another component of the browser. We have a JavaScript runtime. And inside that JavaScript runtime, we have our JavaScript code, the client-side portion of our application. So now we have a lot more power. We can build custom UI components. We can have timers. We can respond to events from the user. We can stop clicks from opening whole other web pages and do something else with them. There's a lot more we can do with this model. It is definitely more powerful. We've also stepped up the complexity quite significantly. We heard in Jack's talk this morning that the number of types of things is an important measure of complexity. We've just gone from one runtime environment to two. There's no longer just the server that we control utterly, that we can choose the version of Ruby, we can choose the gems we install, we can choose what database we have. We now have a second runtime environment that we have no control over at all. It could be any browser, it could have any plugins installed, it could have any features turned on or off. It could be behind a very slow connection or a very fast connection. It could have a big screen or a small screen. There are all these things about that runtime environment that we don't know. So we have more power, but we also have more complexity. Let's go to the next level of complexity. I just added two little arrows to the diagram from the JavaScript runtime to the Rails app and back. Just a couple little arrows, right? It's not that much more complexity. This is AJAX and WebSockets, asynchronous communication between our front end and our back end. These are great. I love these technologies. I'm so glad that we have them. They're brilliant. AJAX lets us build things like the Google Maps interface, where you keep scrolling along and more content keeps loading as you go, and you never have to refresh the page. Way better than the old days of MapQuest. Or WebSockets. I mean, we can have real-time updates in our browser. These are very, very powerful things. But with great power comes great responsibility. We've taken the browser out of the loop here. The browser is no longer responsible for loading stuff, figuring out what it is, and updating the page. We've taken that responsibility on ourselves. The browser is no longer going to help us with things like communicating to the user that a load is in progress, or how far along that progress is, or whether or not it's succeeded or failed, if it's timed out. There's a lot more weight on our shoulders. So we have a lot more power, but we have a lot more responsibility. We're now building a distributed system. We have two pieces of software running on different computers that are talking to each other, and we're responsible for managing that whole thing. We can do great things with it, but that comes at a cost of increased complexity. So is complexity actually bad? Like, we can do cool stuff, so that's good, right? Well, there are two kinds of complexity in software. The first is called inherent complexity. Inherent complexity is fine. It is not bad. It's actually unavoidable. Inherent complexity is the complexity that comes from the problem you're solving. If we were to build a web application where we could file our taxes, that would be very complex. The inherent complexity of the domain would be very high because tax law is very complex. There's no way around it. We couldn't avoid that. It's inherent to the problem we're solving. Similarly, if we were building a web application where the core interaction that the user had with the application involved real-time updates from the server, that's high inherent complexity. We need complexity there to provide complex interactions. But there's another kind of complexity too, incidental complexity. Incidental complexity isn't fine. Incidental complexity can really ruin your day. We heard that song in the lightning talks yesterday about, looking at the code and then realizing it was your own, and it was kind of awful and hard to figure out. That's incidental complexity. When the problem that's being solved doesn't justify the complexity of the code that's being written to solve it. If you've ever opened a class in Ruby and it's doing 16 different things, and each one of them is kind of simple, but because they're all happening in the same place and the code's all tangled up together, that's incidental complexity. Incidental complexity is bad for everyone involved in an application. It's bad for the developer, because no one wants to work with code like that. No one wants to sit down and have to really try and figure out how some simple thing is happening in an application. It's hard to unpick. It makes developers sad. It makes us want to rewrite things. It makes us want to start over because it's just difficult to get anything done. It's difficult to change anything. Incidental complexity is bad for businesses. It makes things take longer to ship. It makes it harder to change in response to user feedback. If your architecture dictates that you have to make changes to 2 applications for a small UI change to go through, that's going to take more time than if you only have to change 1 application. Now, if there's a reason that's inherent to your problem to have 2 applications, then you're going to have to live with that complexity. But if there isn't, then, well, everything's going to take longer, but what do you get for it? It costs your business money. It costs your business time. It costs your business responsiveness to your users. It also costs the users something. Incidental complexity can hide bugs. We heard in the security talk earlier that being able to see code metrics is really good for security because it tells you where the hard-to-understand bits of your code are, and they're probably hiding the security bugs. Well, they can be hiding all kinds of bugs. So if you have high incidental complexity, you could be hiding all kinds of bugs that are going to make your users' lives worse. Also, complex systems can be slower. There's more moving parts. There's more things happening. In the case of a single-page app, when you load the first page, it's often slower because it has to load more stuff from the server and it has to do more things with it before you can just see the content of the page. Maybe that's inherent complexity that you have to live with. Maybe it's incidental complexity that's making your users' lives worse. You don't need it. Progressive enhancement can help, is my claim. Why is that? Well, it helps in 2 ways. First of all, it lets you choose where you accept increased complexity. If you're starting from server-rendered pages with CSS and nothing more complex than that, and then you're layering on enhancements that improve that experience without replacing the underlying layers, you get to choose where you want to take on the burden of having 2 runtimes. You also get to choose where you want to take on the burden of having a distributed system with requests that you're responsible for. You can be focused and targeted. You may not be able to say, oh, we're only going to have 1 runtime, we're not going to have any JavaScript at all. People expect more of web applications these days. But you can say it's important for these features and it's not for those. You can contain it and therefore mitigate the risk. Now, that would be true of any approach that involves server-side rendering. So why this layered approach? Why bother building something that works without the JavaScript and then adding the JavaScript on top? Or without that one specific JavaScript API and then adding support for that as a separate layer to the rest of your JavaScript? Why bother? Well, this, in my opinion, is progressive enhancement's killer feature. It lets you choose when to introduce new complexity, not just where. You can release an HTML and CSS version of a feature to your users on your production application and see what they think. And maybe you've nailed it first time round, and the only complaint that anyone has is, this UI could be a bit more slick. Why do I have to wait for a full page reload? But maybe you've not nailed it. Maybe you're a little bit off. You need some adjustments. You need a few iterations before you get the right feature. Iterating on a simple thing is cheaper than iterating on a complex thing. And once you've hit the point where you know you've got market fit with your application, or where you know that that feature is what your users wanted, when your user testing is showing positive results and you're getting good feedback, then you can double down and make the investment in that feature. You can bring in more complexity to make the experience better and better and more polished once you know what you're focusing in on. Progressive enhancement fits really, really well with lean and agile development. It fits really well in a world where we want to know what our customers think as early as possible. So let's talk about your application. How complex is it, really? And what's inherent complexity and what's incidental complexity? Here I have a scale of complexity from low inherent complexity over there to high complexity over there. I hope I've got those the right way around. Yep. Left and right, turning around, it's complicated. Anyway, so on the left, on your left, low inherent complexity, on the right, high inherent complexity. What about medium? Medium is a very popular platform for sharing articles and reading articles. I can post my thoughts and you can read them. You can post your thoughts and I can read them. Now, in terms of the scale that they're at, there's probably some fairly high inherent complexity on their back end. But in terms of the interactions that they have with their users, the web, even in its earliest days, was great for publishing articles. There haven't been that many technologies that have been added to the web stack that have really improved the experience of reading an article. So I'd say in terms of their interactions with their users, Medium's on the low inherent complexity end. So if I were to build Medium tomorrow, I'd be using progressive enhancement. I'd be rendering everything on the server side. And then I'd probably use some JavaScript to make the writing experience better, because text areas are kind of awful, but could start with a text area and then build up from there. What about Slack? Slack is all about real-time communication. It's all about getting timely feedback from people. It's all about sending messages, being part of a discussion. And also, that's happening in multiple channels, some of which you can't see right now, but you're getting indications that there are messages there that you might want to go and read. There's notifications. There's all kinds of stuff that is core to the interactions that are required by Slack. Slack without real-time would be kind of meaningless. I don't know what you'd do with it. I don't know what it would do. So if I were building Slack, I'd probably use a single-page application. It's on the high inherent complexity end for the interactions it requires for its core functionality. But there's one application that people always mention to me when I talk about progressive enhancement. This has actually happened several times at this conference when I've mentioned progressive enhancement, and people said, yes, but what about Google Docs? Well, what about Google Docs? It's kind of halfway between these applications in a lot of ways, in that there's a publishing and reading articles aspect to it. But there's also a real-time collaboration aspect to it. I can write down my thoughts in a Google Doc and send them to you, and you can read them in much the same way as we could with Medium. But also, we could talk about a piece of work that we're doing together and even make collaborative edits in much the same way as we could with Slack. So where does it fall? Well, the inherent complexity, I would say, is about halfway in between. So what tools would I use if I were to build a version of Google Docs? Well, I'd still go for progressive enhancement. You could render a document on the server side and deliver it very quickly to a browser. And it wouldn't be editable, because you can't do that without JavaScript. And that's OK. That doesn't capture even 10%, maybe not even 5% of the features of Google Docs. But what percentage of the use case does it capture? Now, for me, more than half the time I load Google Docs, it's to read something someone else has sent to me that I have no intention of editing. So even if we're only able to capture 5% of the behavior with server-side rendering, we might be able to capture way more than 5% of the use case. Have any of you ever tried to use Google Docs on your phone? How did that go? I have an iPhone 6. It's the first phone I've owned that is able to even get there with Google Docs. I'm glad that it can. But when I'm on a mobile connection and I'm not on Wi-Fi, it can take 5, 10, 15 seconds before I even get to the content that I'm trying to read. Whereas a normal server-rendered page is less than a second. I'd have a better time using Google Docs if they would give me the content first and then enhance it with JavaScript to give me the editing features. So I draw the line for where I use progressive enhancement versus a single-page app, somewhere around there. Now, I'm not trying to say that JavaScript is bad or that we shouldn't use it. It enables some really compelling application experiences. But that we should be careful to use our tools in such a way that our applications are as maintainable as possible, as accessible as possible to as wide a range of people as possible, and to minimize the complexity so that we can keep working with the code in the long term. I'm glad I can use Slack in my browser. I really am. But not every application has the same inherent complexities as Slack. You might not need real time, and you might not even need updates other than navigating to a whole other page. So does progressive enhancement have a place in today's web? I'd say yes. And I'd say it's in your application. And it's there to help your users, to help you, and to help your business. That's all I have. There's a link there to the slides. The slides are actually a progressively enhanced web application, so there's a ton of notes and stuff in the normal server-rendered version, and then you run the JavaScript, and it turns into a slideshow. So there's notes and links and things there too. We've got about 2.5 minutes left. If anyone has any questions or wants to throw things at me or tell me that I should be doing everything with Ember. Also, if you want to find me afterwards, I have thoughtbot stickers.
Don't you think that the complexity of trying to support all the different plethora of clients via one web app is more inherently complex than building specific clients for specific clients?
So the question was, don't I think that the inherent complexity of trying to support a wide range of clients with a single web app is higher than building specific things for specific types of clients? I think it depends on how you build things. So often with a single page app, all the HTML gets rendered on the client side based on JSON data. If your server can already render all of the HTML in your app, and you're trying to load bits of it to put into the page using client-side code, well, your server already knows how to render the HTML, and running a templating engine or running a JSON serializer are not really that different in speed and things. So you can build in a way where you're doing server-rendered HTML as your baseline, but then you're doing small bits of server-rendered HTML sent to the client to respond to AJAX requests and things. So you're reusing a ton of the same code. Now, if you tried to build a progressively enhanced app in the style of a single-page app, like sending JSON from your server and doing like rendering that to HTML on the client, then yeah, that would probably increase the complexity. But if you keep the rendering all in one place on the server and you just can do like send a single partial rather than a whole layout and template and everything, then I don't think so. I've certainly never experienced a progressively enhanced app where I wished I had 2 applications instead. Any other questions? Cool. Well, thank you very much.